Hello, let us look at some review questions for exam 1 for algebra 2 and trig. Let's try to get started here. The first question, we need to simplify this one. Radical square root of square root of 9a squared plus 16a squared. So the first thing which we have to do is we have to add up these two terms. Then we'll end up getting square root of 25a squared. Now, what is square root of 25? That's right, that becomes 5. And also we have a square within the square root that simplifies as a. So our final answer is 5a, which is choice 3. Alright, let's look at the second question. They want us to simplify this one? Great. Since we have square root, what we're looking for is a squares. Then if you have to look at 50 for a second, we realize that that's equal to 25 times 2. And 25 is 5 times 5. Then knowing that, then this can be rewritten as 2 was already there, and then 5 square. And that's great because we are looking at square root. And r square, once again, just squared. That's great. S to the 4th power can be expressed as s squared times s squared. Now, then as you can see, these perfect squares can come out of the square root. Then we have 5 r, and we have two s's, so we're going to write down s squared and square root of 2. 2 couldn't come out. Therefore, that becomes our answer, 5r s squared square root of 2. Alright, let's move on to number 3. Since here we are looking at cube root, we are looking for perfect cubes. Then if you have to break down 64, we get 8 and 8. And 8 is 4, 2. And 4s are 2 and 2. So you can see that 64 is made out of 1, 2, 3, 4, 5, 6 2s. Now, that means I can rewrite this one as 2 to the 3rd power times 2 to the 3rd power, because we have 6 of them. And separating in the groups of 3 because we have cube root. How about 8 to the 16th power? So you can easily see that we have many 8 to the 3rd power. How many of them do you think we will have? Yes, we could have up to 5 of them. Then, when you realize that, then we have 5 times 3, which is equal to 15. But in fact, we have 16 a's multiplying together. So therefore, we should have one more a over here. And we are looking at index is cube root. So now that means we have 1, 2, and 2 2's will come out, hence we get 2 squared. And a, we have 5 of them right over here. So a to the 5th power is coming out, and cube root of a will be left, because all the values will be able to come out except the last a. Then therefore our final answer becomes 4a to the 5th power and cube root of a. Choice 3 becomes our answer. Alright, let's look at number 4. Once again, we're looking for cube root, so that means we're going to break down the numbers and then make the groups of 3, or cubes. So here we get 54 breaks down into 27 and 2. And 27 is 9 and 3. 9 is 3 and 3. So that's great, because here if I have to rewrite it, cube root of 2 times 3 to the 3rd power, because that's what makes 54. And a to the 7th can be rewritten as a to the 3rd, a to the 3rd. In total we have 6, so we have a left over. And b-wise, b to the 3rd and b left. Then in this case you can see that one group of 3 and 2 groups of A's and 1 group of B is perfect cube, so we can bring those things out. Then we end up getting 3 from the first 3 and then 2 A's, so hence A squared, and B were able to come out, and cube root of 2AB. Those are the remaining values within the radical. So that's how we can simplify it. Alright, let's go for number 5. Now we're looking at fifth root. Then we are looking for things that has fifth power. So let's look at 243. So negative is right over here. So I don't know how it goes, but we'll see what happens. I'm just going to break down 243. What if I have to try 3? That's right, then it becomes 81. And what if I have to go for 9, 9, and 3, 3 for each 9? Then you will realize that 243 is made out of 5 3's multiplying together. But since we have negative, I can rewrite this one as fifth root of negative 3 to the fifth power. Then it will still be negative anyway. And how about a to the sixth power? I can rewrite that as a to the fifth and a. And how about b to the 12th? I can write it as b to the 5th, b to the 5th, and b squared. Then here we can see that this one is perfect. A fifth power, another one. This one is b, and then b. There it goes. So here we get negative 3 and a. But we have two b's coming out, so hence we get b squared. And then the rest of them will be remaining in the radical. Fifth root of a b squared. So that becomes our final answer. Alright, let's look at number 6. Here, what are we going to do? We're going to first multiply or divide, and then we're going to simplify after. So then here we get 108 and x to the 5th power and y to the 8th power divided by 6x and then y to the 5th power. Then x cancels out, becomes 4th power now, and y to the 5th power cancels out, becomes 3rd. And then what happened to 6? 108 divided by 6 simply becomes, yes, it becomes, I believe, 18. Then denominator cancels all cleanly out, and then we are left with square root of 18 and x to the 4th power and y to the 3rd power. Then what makes 18? That's 2 and 9, which is 3 and 3. So here I can rewrite this one as 2 times 3 square and x squared because we are looking at square root, and y squared times y. Here we get perfect square right over here. So then here we have 3x squared and y and square root of 2y. Alright, so that's that would be our answer for number 6. And let us move on to the next question. Here we have this expression, and we like to simplify them. Then add or subtract. But before we add or subtract, we have to simplify first. So first one is already simplified. Then let's look at the second one, especially the inside value. So here what I like to do is, let me try to simplify this radical right over here. and then multiply that to 3a. Since square root of 18b to the third power can be rewritten as this way. So 18 is, as we have done earlier, 3 squared times 2. So here we get 3 squared times 2, and then b to the third power is b squared times b. Hence creating 3 and b can come out because they're both squares. So 3b is what we can take out, and square root of 2b is left. So we can put this one in this location and then rewrite down the expression. Then what do we end up getting? First, I'm going to copy down 4ab and square root of 2b. Now, when you look at it, I have 3b and then 3a. When I multiply them together, carrying the negative sign, it will be 9ab and square root of 2b. And lastly, we have plus 7ab and square root of 6b. Then what happens? Now try first two terms can be combined together because they are like terms. So we have 4 minus 9, which is negative 5 ab and square root of 2b plus 7ab square root of 6b. Now then you can see that here we have they look very similar, but one is 2b, the other one is 6b, so I cannot combine them anymore. And that gets us the answer as choice 4. Becomes our final answer. Alright. How about number 8? So here, what are we going to do? We have to multiply top and bottom by the radical. Then I'm going to rewrite this one as 3 over, I'm going to make it a bit longer here, square root of 3 a square b. Then what don't I multiply? 3 a square b. 3 a square b. Then you can see that bottom becomes simply 3 a square b, because we have same thing multiplying together. How about the top? Notice that a squared is perfect square, so we can bring out a. Then we get 3a and square root of 3b. Then here you can see that 3 cancels out, and a cancels out with the a squared. So what we are left here, left with, is square root of 3b over ab, and that becomes our answer, which is choice 3. Alright, number 9. We realize that denominator has 2 terms. Then in that case, we have to multiply top and bottom by its conjugate to rationalize the denominator. Then here we have square root of x over square root of x minus 1. Then we have to multiply top and bottom by x square root of x plus 1. It's the same thing as the denominator except the sign in the middle. So square root of x plus 1. Then what do we end up getting? On the bottom we get our first one times first one is x, and plus square root of x. Negative 1 times radical x becomes negative radical x, and minus 1. And on top, radical x times radical x is x plus radical x. Then you get to see, you get to realize that the two bottom terms cancels out because one is positive and one is negative. Then when I simplify this one, on the bottom we get x minus 1, on top we get x plus square root of x. So which is choice 2. And that becomes our answer. Alright, let's look at the next question number. Alright, so then here we have number 10. Let's try to multiply them. What are we gonna get? First one times first one, we end up getting square root of 4. We know that to be equal to 2 anyway. And then first one and then the last one we get plus 3 square root of 2. And then of the next set we get minus 3 square root of 2. And then the last one portion we get negative 9. Then as you can see, the bottom one, the middle ones cancels out. Then we end up getting 2 minus 9, which equals negative 7. And that becomes our final answer. Alright, let's look at this one. So here when I multiply the first one to the first term here, we get 2x squared times x, hence we get 2x to the third power. And square root of 9x. We have two y's here, so we get y squared. And minus, when I multiply that factor by the second term, then we end up getting 2x squared, because we only have one as an outside coefficient, and square root of xy to the fourth power. Then you can easily see that 9 can come out, and then y square and y to the fourth here. So the first term now becomes 2 times 3, which becomes 6x to the third, and y squared comes out, becomes y and square root of x. Minus, here we get 2x squared, and then y to the fourth comes out, becomes y squared and square root of x. And that becomes our final answer because we cannot add them up anymore. Number 12. So here we have essentially when they want us to multiply this one, then what they're saying is 1 plus square root of 2 times 1 minus square root of 2 and 1 minus square root of 2. That's basically what we're looking at. Then let's multiply the first two first. Here I get 1 times 1 is 1. 1 times negative radical 2 becomes minus radical 2. Radical 2 times 1 becomes plus radical 2. And radical 2 times negative radical 2 is minus radical 4. Then two middle terms cancels out, as you can see. I get 1 minus 2, which is equal to negative 1. So entire first two factors comes down to negative 1. Multiply that by third factor, which is 1 minus square root of 2. Then when I multiply those two, I get negative 1 times 1 becomes negative 1, and plus radical 2 becomes our final answer. Alrighty. So that was number 12. Let's go for number 13 here. So then in this case, when I'm trying to multiply, what do you do with the exponents? That's right, we just have to add them up. So we get a to the negative fourth plus 6. Because when you multiply, we gotta add up the exponents. We end up getting a to the second power. That's it. Choice 13. Number 14. When you have negative 1, what does that mean? We're going to get the reciprocal within the absolute value, and within the parentheses. You can assume that this one is simply over 1. So our answer is 1 over 3x squared. That's all we have to do. you see the negative exponent means it either get the reciprocal, or if it's in the numerator, it will go to the denominator. If it's in the denominator, it will go to the numerator. So in this case, our answer will be choice 1. So number 15, you see all this negative exponent. Notice that this negative 2 here only affects x, not 2. So this, now you can realize that 2 and 4, which weren't affected by the negative exponent, will be the same location, and x now has to go to the denominator, x squared. Y also has to go to the denominator, and then y to the negative 5th power becomes now numerator. And here we get to realize that that's equal to 2, and this cancels out with this one. We get y to the 3rd power. So when you combine them together, we have y to the 3rd on top, and on the bottom we have 2x squared. Alright, then what is our answer? It seems like choice 1. Alright, let's look at number 16. Same deal here. So negative exponents, meaning these two has to change its location. So here we get a squared times a to the 4th, because whatever was negative has to go to the top, and then b to the 3rd, because it used to be on top, now it has to come down because of the negative exponent, and b squared. So on top we get a to the 6th power, because we got to add up the exponents. On the bottom, b to the 5th power, because we got to add up the exponents. So it looks like choice 1. And in fact, we're going to stop here, and I'll see you later. Have a great day. Bye.